All right, so this is the last section in this organic chemistry unit. In this section, we will learn about molecules that go beyond the simple carbon-carbon single bond called alkanes. Okay, so here's a picture of some molecules that have features that are very different from just single carbon-carbon bonds and single carbon-hydrogen bonds. We have here acetic acid, which is a molecule found in vinegar. We have here propyl acetate and pentyl acetate, both molecules that are responsible for the smell of pears and bananas, respectively. See how they're kind of similar with each other? And then lastly, we have here methylamine, which is a molecule that is responsible for the stinky smell of a dead fish. Okay? And beyond that, there are some other molecules like methyl salicylate, which is responsible for the smell of mint, methyl jasmonate, your jasmine boba tea, that's a smell from that molecule. Limonene, not surprisingly, is a molecule found in lemon. And then butter, the smell of butter is from this molecule called acetylene. Notice all of these molecules don't simply have a carbon-carbon single bond, but they have something else, right? They have maybe a carbon double oxygen bond, a carbon oxygen bond, and other kind of motifs, other kind of patterns in the way the atoms are connected. Okay, and beyond this is also very important because in medicinal chemistry, a lot of molecules have these kind of motifs in them that give them a different activity for drugs. For example, here in 2014, Crestor made $5.8 billion. It's because of this very relatively simple molecule, whereas this simple molecule made $5.5 billion, sold as Privia for asthma, and then this molecule, see how they're all different looking, right? So then there's things about them that make them have their functionality. This one right here, lastly, was Gleevec, $5.1 billion in fighting leukemia, and we'll come back to these when we learn about functional groups. So again, formally, let's discuss what functional groups are. They are characteristic features of organic molecules that behave in a predictable way. That's why we want to give them, group them together. Whatever patterns we see in nature, we try to group them, right? The function groups are defined by the kind of atoms you have or the groups of atoms you have. And they're just, again, a way of classifying families of organic compounds. So again, in this section, we're learning about compounds in organic chemistry that goes beyond alkanes. And then when we learn about alkanes, we have to learn how to name them, right? So this section is too wide and too large to know how to learn how to name them. So I'm not going to make you, if you're in my class, name these alkanes, these molecules. But if I give you a molecule, you should be able to circle them and identify by name the functional groups that are present in that molecule. So, all right, so let's now go and start looking at these functional groups. The first groups we're going to take a look at are quite simple because they still contain carbon and hydrogen atoms, but they have other kind of bond differences. For example, when we talked about an alkane before, we are talking about carbon-carbon single bond. So instead of having a carbon-carbon single bond, if you throw in a double bond, you are now called an alkene. And if you have a triple bond, you are now called an alkyne. And then lastly, if you are a double bond in a ring, three double bond in a ring like this, you have a special name called aromatics. Okay, so let's take notes about that. So alkenes that contain a double bond between two adjacent carbons are called alkenes, and then alkynes are those that have a triple bond in those adjacent carbons. Again, you can represent them like this or like this. Notice then that how many bonds are connected to an alkene. Since an alkene is a double bond, it already has two bonds, so it can connect to only two other atoms. Whereas an alkyne has a triple bond, so it can only connect to one other atom because of the octet rule, right? It has four partners or four bonds. Okay, then lastly, there's your aromatic. You can represent aromatic like this, or in a circle like this, because those double bonds, they can rotate and in that. All right, so let's now move beyond and add one more atom to this mix. And the first atom we would like to add is the oxygen, right? So if you now have an oxygen to that, you are now called an alcohol if that oxygen is bonded to another hydrogen. It also has a special name called hydroxyl group. So again, if you're an oxygen connected to a hydrogen and connected to another carbon, you are called an alcohol. Okay. Now, what's below the periodic table? What atoms below that for oxygens? In a periodic table, you have sulfur, right? So because of that, they have very similar reactivity, so the names will also be similar. So if you are sulfur instead, a sulfur connected to a hydrogen connected to an oxygen, let me say that again, a sulfur connected to a hydrogen connected to a carbon, you are called now a thiol, similar to alcohol. Right? Let's go back to the oxygen case. Instead of being an oxygen and then carbon, hydrogen, instead of that, you have oxygen and two carbons. You are now called an ether. Okay, an oxygen atom bonded to two carbon atoms. Moving on is another class. This is a big class called a carbonyl, and this is an umbrella class. And underneath it has multiple functional groups. But what is a carbonyl? It's simply carbon-oxygen double bond. Whenever you have that, you will have a carbonyl. Now below this, you have aldehydes, ketones, carboxylic acids, esters, and amides or amides. That should be a D, not an N, my bad. So let's talk about all of those function groups one at a time. All right, so all these functional groups all have a carbonyl, and on one side is carbon, right? Carbonyl, one side is carbon. Whatever is on the opposite side defines the specific function groups of that carbonyl. So for example, if you are a carbonyl attached to a hydrogen, you are called an aldehyde. If you are a carbonyl attached to two carbons, or just this carbon's never going to be different, right? So it's the same over here. But on the other side, if it's now connected to another carbon, you are called a ketone. Again, keeping this in mind, you have a carbonyl attached to something else. If it's attached to an oxygen, hydrogen, the hydroxyl group, it's not an alcohol, it's a carboxylic acid. Now, instead of an alcohol, instead of being a hydroxyl group, there's OH. Now it's O and carbon. So a carbonyl attached to O and carbon, you call it an ester. And finally, if you're a carbonyl, again, attached to a nitrogen, you have a special name called amides or amides, however you want to say it. Okay? And this is an example of an amide. Urea is a very simple amide or amide. And then if you just a simple nitrogen without the carbonyl, you have a special name, and you are called an amine. Like ammonia is a type of an amine. It has a nitrogen connected to either a carbon or a hydrogen. Doesn't matter. As long as it's not a carbonyl, you're an amine. All right, so here is the whole list of functional groups that you are going to be responsible for. So go ahead and make flashcards for them. So let's go ahead and apply what we just learned in these compounds here. All right, so what would you call this? You call this a carbonyl connected to a hydroxyl group, so that's a carboxylic acid. This is hydroxyl group only, so that's alcohol. What's it called this? Alkene. What about this guy? Aromatic, right? We'll skip these for now. A nitrogen connected to carbons, amine, an oxygen connected to two carbons. What is it? Ether. And then this one, a carbonyl connected to an oxygen, ester, right? So therefore, this is an amine. Sulfur connected to two carbon, that's called thiol. All right, and some more over here, we have a carbonyl attached to a nitrogen. What do we call that? An amide, aromatic, and then nitrogens attached to each other. We call that an amine, right? And what else? Yeah, everything else is the same. All right, cool. So that's all the organic chemistry you need to know for this unit.